So we'll start out with this basic sort of default bit stream that you get when you first power the board on. What's immediately going on is you can see that on the 7-segment displays, you just have this pattern that counts up about every second or so, counts up till 9, and then it wraps back around to 0. And this display can be sort of controlled with the 5 directional buttons right here. So each of the directional buttons will disable one of the 4 digits. So down will disable the first one, right the second, left the third, and then up will disable the last one. This center button, when it's held down, will disable all 4 digits, and will also reset back to 0 when it's released. So regardless of what it's at, when that center button's released, it'll always wrap back to 0. And these switches down the bottom are set up pretty simply. Whatever switch you flip will automatically turn on the LED above it, and that center button will also disable the bottom row LEDs. That's about as far as it goes for the default. So if we go over and hit program, then we get the actual custom bit stream that I loaded onto the board. And I guess we'll start again with the 7-segment display. So there are 2 sort of basic controls. The center button will just send every LED on the board high, at least all these output LEDs, including the 7 segments. And then the down button will do exactly the opposite. It'll send them all low. Then we have the left button, which when this is held down, it will display this counter that seems to count up in seconds, and it wraps back to 0 whenever it hits 60 seconds, or I guess 1 minute. So we see that's at about 47. The up button will also reset that counter. So you see that's back to 0. You can hit that again. Wraps back to 0 again. And the right button displays this sort of incrementing pattern on the bottom LEDs. And something I did notice with that is that the pattern doesn't pick up where it left off the last time you press it. So what it seems to be is that there's sort of a constantly incrementing value that's always running in the background, but it just only displays that pattern when the button is held down. And we can move on to these this digit that's displayed here with these four switches. These first 4 switches, switch 0 through 3, and these basically just represent 4 binary digits. So if I flip the first one, we'll get a 1 on the display. If I set it to a 2 in binary, we'll get a 2, 3, 4, 5, 6, 7, and so on, and that'll count all the way up to F. It'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. It basically counts up in hex on that first digit of the 7 segment to represent those 16 binary values on those 4 switches. I think the last thing to go over is the next 3 switches, switch 4 through 6. And these took a little bit more figuring out to see exactly what's going on behind the scenes. But essentially what I initially figured out is that there are 4 different states for these 5 LEDs, and it depends on how many of the switches essentially are turned on. So if there are 0, if none of the 3 are turned on, you'll get these 2 LEDs. If any single switch is flipped, you'll get this sort of 1 and 2 pattern. If either combination of 2 is flipped, you'll get this pattern. And if all 3 are flipped, you'll get just those last 3. And so I was trying to figure out exactly what the pattern was. And so over here I sort of diagrammed the combinations you'll get. So over here we have the number of switches that's flipped, and then all these patterns of LEDs. You have these columns of which LEDs are on in which positions. And after a little bit of going through it, I was able to figure out that each LED seems to be tied to a 3-way logic gate based on those 3 switches. And so the LED 0 seems to be tied to a three-way AND gate, LED 1 to a three-way OR gate, LED 2 to a three-way XOR gate, which gives you that only on in with odd numbers of inputs. And then LED 3 is tied to a three-way NOR gate, and LED 4 to a three-way NAND gate. And so if you mess around with those switches, that should hold consistent for each of those. They should behave just like those gates do. And I think that is about all there is from what I have written down there. So there you have it. That's Lab 1. That's about all there is to both of those different bit files as far as how everything behaves and what's going on behind the scenes.